Okay, carrying on with this paper. Scientists collect data from grassland ecosystem. Each trophic level, they determine the mean number of organisms in a square meter, the mean dry mass of these organisms in a square meter. Right. Trophic level. What is a trophic level? So these there's two ways of looking at it. You can say that they are energy levels in a food chain, or they are, what do you call it, feeding levels in a food chain. There you go. Right. Now, the next thing that we want to just quickly look at is ecosystem, because these definitions do come up. They might ask you. Right, ecosystem. Right. You can say it is the community of organisms, living things, interacting, if I can spell that properly, interacting with its environment. Use the word physical environment. So trophic level and ecosystem. Right, if I come across a more concise definition, we'll make a note of that. Right, they're saying the producer that makes his own food, primary consumer eats the producer, and so on. Yeah, 2 and 3. So we've got we've got 4 trophic levels. Right, mean number of organisms, it goes down. The dry mass goes down. Right, so we need to draw a labeled pyramid of numbers, not mass, numbers. So what I tend to do is I start at the bottom, producer. 500, and this is just over 50, so it'll be about a tenth of the size, but I don't want to make it, I might not be right in there. Primary consumer, and then we've got half of that roughly, secondary consumer, and then finally we've got 3, so it's about a tenth of that, and that is tertiary. Tertiary just means third consumer. So that is a pyramid. Yeah, it's a form of a triangle. Right. Describe how you could collect data to find the mean number of producers per square meter. Right. This is again a standard answer. So the first thing I would write, I will use a grid system and generate a, and this is the key, random number, and just add this on a computer. Yeah, I will place the quadrat, it's not quadrant, yeah, he says it's quadrat, quadrant, that's not it, it's a quadrat. I place the quadrat on the random location. I will count, I will count the plants. Yeah, then I will repeat, say 5 times. Standard answer, I will remove any, let me just get rid of this word and put it in caps, and remove any anomalies, and average out. And you just got to make sure that the quadrat is a 1 square meter, and you've got it. So the key things here is like use a grid system and use a random number to place it on. Use a quadrat on the random location chosen and count the plants, and then repeat it, remove anomalies and average out. It's a standard answer. That covers everything. Right, now comes the maths part. The mass of organisms at each energy level is called biomass. So biomass is the total mass of living organisms in the area that you're looking at. Yeah, so the percentage of biomass that is transferred to the primary consumer is 4.5%. So what they're saying is if you've got 100 kilos of grass, the caterpillars are only going to pick up 4.5 kilograms. So they'll grow 4.5 kilograms. Yeah, so it's only transferred that much. So what we do, calculate the percentage of biomass to the secondary consumers that is transferred to the tertiary consumers. Ooh. Okay. Where's the calculations? Right. So it's these two numbers we're interested in. So I'll tell you what, let's just take a copy of that. New down there. There you go. So we're going to multiply the output with the input. So remember, it's only 2.40 has been transferred out of a total of 10.60. I didn't even look at that. Grams. Okay, and then how do you turn a fraction into a percentage? multiply by 100 and you get 22.6%. They will accept 23%. That's fair enough. Right, comment on the energy transfers in an ecosystem. Again, it's that standard rabbit question. Okay. Right. Right, okay. Right. First of all, this is what they've said. There are fewer organisms on top. There are fewer organisms on top. So less biomass. Right. Energy is lost at each trophic level. Why? Because you have not all biomass eaten. So for example, if you have grass, the roots are not eaten. Some of it dies. Some biomass dies. You also get some is excreted as cell waste, as respiration waste, excreted as respiration waste. What else is there? Right, okay, digested. Not all is digested. So not all is digested. Right, okay. So first of all, right, you'll get a mark for that. You'll get a mark for that. You'll get a mark, so there's less biomass at the top. And then you'll get 2 marks for any one of these. Yeah, 3 and 4. Yeah, so most of the energy is lost straight away from, where are we? Between the producer and the primary consumer. That's the biggest loss. Right, let's move on. What? 13 minutes, that's fine. We've got time. Let's leave it at that. Right, so it's to do with, that looks like as if it's a wind pollinated flower. So that feathery part is the stigma. It catches pollen flying in the wind, and wind pollinated pollen is smaller and there's lots of it. It doesn't have to be prickly, it can be smooth. So what will happen is it'll be flying past, and if it needs to get to the stigma, because these are, it's much large surface area, it's more likely to catch 1 or 2 or 3. Yeah, right. Let's get rid of that. So that's the stigma. Right, what's the next one? That, oh, whatever. There you go. There. That is the anther. It's outside, exposed to disperse the pollen. So the pollen is going to fly off from here as soon as there's a gust of wind. Yeah, so let me put it this way. Always this is the pollen producer, and it's the male part. This has the and I'm assuming it's in here. That's the ovary, and I'll have the ovules in there. So it's the ovum produces the egg, so it needs to catch the pollen. So it's the female part of the plant. And WX and Y is that's the bit connecting the anther to the plant, is the filament. Right, okay. So a bit of wind, it'll move and the pollen will dislodge and get carried away. Describe how the structures WX were adapted for wind pollination. Right, okay. First of all, the stigma. So name it first. The stigma has a large surface area and is outside the flower, right, to catch pollen. Next one, the anther is outside the flower again. So remember, these will have small flowers. The anther is outside the flower to disperse the pollen. Last one. Right. Y is the filament. So filament is long and I won't use the word floppy, I would say not rigid, and not rigid to allow it to move in the wind, wind to disperse pollen. So there's loads of little features that these plants have got. They've evolved to do that. Structures are adapted for wind pollen. Give two the differences between, right, okay. What do you call it? Insect pollinated flowers have large petals, large colored petals to attract. They also have insect pollinated. So always put this in because there might be confusion if you're talking about insect or wind. Insect pollinated plants have nectar to attract insects. Okay, let's keep moving on. Right, wind pollinated flowers often cause an allergic reaction. Right, this is a tough one. This is known as hay fever. Most people in the UK who get hay fever have symptoms from April to September. April to September. The graph shows the changes in total pollen count for 3 different plant types: tree, weed, grass. Okay, June, July, grass has got loads of pollen. Trees have it April, and well, that's weed. Weed. Oh, see, weed. It never gets to the pollen stage because it's always cut and disposed of, isn't it? Right. So from May. Oh, it peaks around here then. Okay. Right. So that's total pollen count. Yeah. And this is the time. Right. As part of an investigation into pollen allergy, 5 people keep a diary of their hay fever symptoms. They do this for the same year as the pollen count. So person A, severe symptoms, mild, no symptoms. So no symptoms in July to September. None there. None. So so this person's not got hay fever. This person's got some hay fever because they're exempt here. Yeah. And these 3 people have got different types, March to May. Right, that'll be interesting. Use the data. Oh, right, we're gonna have to do that one again. We'll cut it and take it down and see what happens. So we need to use the data. Right, okay. Pollen number and symptom. Right, okay, we can say April. Oh, that doesn't help, does it? Right, let's get this right. This one, April to May, is 3. Okay. April to May, so let me write this down. April to May is 3. April to, so 3. March is 3. Okay, there's nothing, there's only 3. Grass, no, grass is always there. June, July, so what they're saying, no, let's do it down here. March to June, what's happening in March all the way to June? So that is 3. March to June is 3. April, May, okay. Right, grass is June. It peaks June. Is there anything in June? June and July. Okay, so this looks like as if it's going to be grass. March to May, August. Where's March? March. Oh my God. Weed. Weed goes up and down actually. Right, no, because it peaks here. The weed peaks here, so that's no good. So what we'll do is it does both. March April, May, June, March, May, August. March, May, August. So it's, yeah, it's gonna have to be tree and what's that? Tree and grass. Tree and grass. Right, what happens in March? Let's have a look. March. Nothing really happening in March. March is mild, so what kicks off in March? Really, it's tree. Okay, March is tree. So it's mild because there's not much of it about. That makes sense. None. June to September. What's happening June to September? Right, so that'll be grass and weed. So this is grass and weed. March to May. March all the way to May. That'll be tree. There you go. That's just good having the paper in front of you, but okay, we've got that. So now we need to link. Right, so we can say July to September. Yeah, we can say person D has no pollen allergy. Yeah, that's the first one. Number 2, person B has some mild allergy to tree and weed. Person B, yeah, tree and right, let's have a look. March, April, May. Which is weed? Weed is there. March, April, May. Weed, yeah, it's weed. I put grass. Grass is yeah, so it's peaked. It peaks up here, the grass. So so grass peaks for person B. Person B. You've got severe June to July, which is grass. Where's June, July? Right, it's grass and weed. June, July, May. So person B has main symptoms. So person B has severe reaction to grass and mild to tree and weed. Guess I've already said grass. That should have been weed. Okay, person C. Tree. March is tree, and April to September. April through to September, and okay. So person C has allergy to all three pollen. And yeah, okay. So because it's there and there. Yeah. Right, we've said that. Right, we're after now. What about E? Grass, weed. Grass and weed. June to September. Where's June? All the way to September. So okay, so it'll be grass and weed. Yeah, and a mild. So okay. Main person E. So we've done B, C, D. Okay, main allergies. Person E has to grass and weed. March to May. What's going on in March to May? That's true, but that'll be mild, right? And then you've got, and you can say mild to tree pollen. Okay. Person A, I forgot. Person A. Tree. Person A has allergies mainly to tree. What was it? Tree pollen. Yeah. July to September. July to September, yeah, that's when the tree pollen's gone. So really, yeah, I suppose it's a side effect after that. Right, okay. That was a tough one. Right, so that was that part. Now we need to discuss the other parts. Right, if you notice that no species has a level pollen has a level pollen count. Right, and what they've just, okay. Another thing what they've done is, what are the negatives of this? No repeats, only done over 1 year. There's no details on species of tree, what's it, grass and weeds. So if you had to repeat, you won't know, or whether it's even native or right. Okay, right. Right, what is an immune response? That's what we need to do. So body's immune response. Again, a lot of these definitions are coming up, so it looks like as if you're gonna have to. So immune response is the body's response or reaction to pathogens where white blood cells, phagocytes and lymphocytes, where white blood cells, the lymphocyte cells react. Lymphocytes produce antibodies, and the phagocytes engulf pathogens and digest them and kill them. Okay, I think that's gone on. Right, okay, that's the next question. We'll do that on the next video.